Hello and welcome to problem 13. In this problem we need to find the first 10 digits of the sum of the following 150 digit numbers. So this is a very easy problem actually. So there is in Sidef we have support for arbitrary large integers, and we can simply sum these numbers together and get the first 10 digits, but we are going to do something else. We are going to use an addition algorithm. So just like when adding it by hand, we can do it in programming. So we have here a function log addition. We take two strings a and b, and we want to add these two strings together and return the result as a string. So first we can start by breaking the strings into characters. Then we need to flip the list because we want to go to work backwards from the last digit to the first one. Then we map it to a number, so each character is mapped to a number that we can work with, and we do the same for b. So here if I print say and I print a and b, I shall get two arrays, right? So they are in reversed order, and so this is just like doing addition by hand. So let's quickly illustrate how this will work. So for example, when I have these two numbers, I go from the last digit. So I say 4 plus 6 is 10, so I write 0 and 1 is remembered. 3 plus 3 is 6, and with 1 is 7, right? So we go like this, right? And we want to do the same thing here. And to do that, so here if you can see, when we say 2 plus 0, 1 plus 0, we don't say it, but this is really 0 in front of 1 here. There are 3 zeros here, and let's do that. So to do that, we need to take the length of the maximum length between a and b, and we want to append how many zeros? We want to append l minus a len of zeros, and the same for b. And if I print here, let's comment this out. So if I print the result again, so this one has 3 trailing zeros before 1, right? So we have the same length here when we want to add them together, like that. Okay. So I also need to create the result array, which is also an array of zeros initially. Let's call it L of 0, and I need to iterate over the range of the arrays, right? So for I 0 up to but not including L, I have C of I plus equal with A of I plus B of I. So these are these two numbers here. So for example, when I is 0, we have 4 plus 6, and we store the result in Ci, which is the new array which will store 10. So because so we need to check if C of I is greater or equal with 10. We want to set C of I to the remainder, and Ci plus 1 to the quotient of division by when divided by 10. So we can do this by using the diff mod method, defining into the language. So diff mod of 10. So for example, I have here what is 15 diff mod of 10. It's 1 and 5. 1 is the quotient, 5 is the remainder when divided by 10. Okay, so I set I plus 1 to the quotient and I to the remainder, and here we can return the string. We can join it and then flip it, or otherwise, and let's print the result. And if everything went right, this should be correct. Let's check it. Yeah, so we have here an addition algorithm, a very basic one, and now we need to add all these numbers together with our algorithm. So first we can start by setting a value, some value to 0, then iterating over the data, each line, so maybe each n, each number, so sum is equal to long addition of our current value of sum with n, then here we say sum first 10 digits, and let's see if this works. Yeah, it did. Okay, so here we check the result. Yeah, so it is indeed correct. That's great. Okay, so maybe as an exercise you can think about allowing different bases. For example, instead of saying here 10, we maybe want to have a parameter here, base is equal with 10 by default, which is a number, and here we want to use the base, right, to allow that. But here we also need to map the result to that base, and here when we map the numbers we need to map it to that base. So this is an exercise for you to work out if you want. Right, so that's it for this one. Thanks for watching, and see you in the next one.